Hello, everyone, and welcome to the deep dive responsible and unbiased Gen AI for computer vision. My name is Dan Grau. I'm a developer evangelist at Voxel 51. Today, we'll be talking about the crossroads of Gen AI and computer vision. We'll be talking about the traditional augmentations that we've been seeing in computer vision and how Gen AI is now emerging into this field. We'll talk about some of the fears of the future, as well as the poison and the antidote when adding Gen AI to your datasets. Now, it's to no surprise to anyone following that Gen AI is exploding onto the scene. We see tools like DALL-E and ChatGPT being the fastest online platform to reach 1 million sign-ins. And it's being marketed as this tool for all solutions, right? There's nothing that you can't accomplish with Gen AI. And to some level, that's true. We see this clear runway, but we're still waiting for its pilot, right? A tool is nothing without the tool being held in your hand. And we can see that with Gen AI very clearly. We're also seeing in computer vision that not all data is perfect, right? More and more, we see these new models coming out, and your model will switch every year, but the data that you've trained on actually stays the same. And that's why it's important to take a large look into your data set. And things like low sample size, low variety, or just poor quality data has been an obstacle for computer vision for decades. And we've just been limited by either our resources or compute, whether that's resources to collect more data or compute to change our data, and just understanding both on the domain of data collection and our domain of just computer vision in general. But that's okay. We have these image augmentation techniques, and with Gen AI, it is exploding into this field in computer vision. Before, we were limited by compute and resources, and today we're just really limited by our creativity of how to apply these new tools to our data sets, as well as our curation afterwards. We'll start with our traditional synthetic data sets. This is as far away from Gen AI as you could imagine. And these are data sets that are generated using some kind of 3D platform, whether it's an engine or something like Blender. And these synthetic data sets are great for things like having unlimited control over a 3D scene. If you need an image data set, you can drop in models, you can change the camera angles to have all this control. And this insightful metadata of things like where the camera is or what models you've used leads to very powerful data sets, as you can store all these inputs as well. It overall leads to this very highly customizable workflow where you can change almost every aspect of your data collection in this synthetic world. However, we see that multiple points of inputs lead to multiple points of failure, and that you often get into this game of telephone with synthetic data sets with maybe something that was an input that needed to be specified has now been lost down the road. I actually saw this firsthand when working with synthetic data sets. When we asked for a car data set, we wanted to make sure that we saw the car from every angle. That led our synthetic data set to look like this image here, where 50% of our data set was the upside down or bottom of the car, rendering half of it useless. And really, we wanted every angle like up and around the car, right? Not just on one axis. You also see that you're highly reliant on the engine. If a lot of these images look like they're coming from GTA 5, it's because they are coming from GTA 5. It's one of the easiest ways to generate synthetic data. And overall, this experience leads to a very high barrier of entry. You need a very large set of skills, as you can see on the right. This is an outline of all the different steps that go into generating a true synthetic data scene. You're not a single person learning all these different skills. You're now going to have an entire team that come in at multiple different points that longs into this long chain of process that makes it very hard to iterate fast and very expensive, both on a technical level and a compute level. So we also see image augmentation, right? Image augmentation is now we're moving more towards our images, and how can we change our existing images to make them better for our model to learn on? Traditionally, we see very basic transformations, things like horizontal flip, cropping, or changing the brightness or values within your images in order to have these low-level transformations that are meant to patch the gaps in your data. By flipping around or changing the brightness or cropping, you're giving your models something else to look at, something else to train on. We see this being revolutionized or still upgrading, innovating in the field, where we see things like mosaic augmentation here on the right. This comes from the YOLO v4 paper, where we're actually cropping and adding multiple samples to one image. This way, your bounding boxes are changing their localizations. They're getting bigger, they're getting smaller to help your model learn exactly what you're trying to find. But they all fail to capture one big thing is that it's hard to tell a story by just flipping a picture, right? If I have a data set that is full of black cars and I need to cover the gaps in my data sets, such as I need more white cars, I can't really accomplish by just flipping my picture or, changing my brightness value. There's a more story. These are images. There's more of a story to tell within an image than just flipping it around. We also see that repairing an image's quality is very difficult. A lot of computer vision tasks either need higher resolution or are training on poor data, whether it's hard to collect or the sensors introduce noise, where these then down the road make for hard computer vision problems. And overall, we're just failing to capture the higher level feature representations of our data sets. Our data sets are so much more than just their pixel values in a box or just what their brightness or flipping could be. There's much more to our image than just that. And this is where we see GenAI just fitting in perfectly for computer vision. We're going to talk about a couple of different ways that it's shaking up the field. And we're going to start with super resolution. Super resolution is a method you can use with GenAI where you can either increase the resolution of your image or repair it in some way. We can see on the bottom left our blurry image being super resolutioned to be high res, and you can go up to 4, even 8, 16x sometimes on these models to go turn a standard depth picture to 4K or 8K potentially. We can also remove noise from our data sets, like we see here, where we can remove any blurriness or noise to make a crisp picture every single time. This is great for things like reading license plates in traffic, where the blurriness or the noise of these old cameras make it hard to read. Or you can actually even restore old images like here on the bottom right, where we can feed in these old images and pop out a restored version. The models we see shaking up in this field are HAT-L and WaveMix SR, currently performing the highest on the competition datasets. The next one we're going to take a look at is inpainting. And inpainting is taking your original image and then painting on or actually removing some object within your image. We can start on the bottom left where a whole image is being inpainted here, where we can actually add weather. So if you have these outdoor data sets where you need more rain or you need more snow or you need cloudy days, we can actually alter different days within our data set to fit all these different cases. In the middle, we can target objects such as this bungee jumper and remove them from our data sets for either data privacy reasons or just to make the model more focused on what it needs to learn and remove distractions. Also, just like we saw before with super resolution, we can repair images such as tears or missing parts of the image and use inpainting with the mask you can see on both the middle and on the right to then fill in these gaps with the model's best guess. The best models that we've been seeing are the stable diffusion, DALL-E, and inpaint anything models, but new models are coming up every day in new versions of existing ones. The last one that personally excites me a lot is geometry-aware augmentation. If you've ever had to deploy a camera actually out with a model ever before, you'll be very appreciative of this one, where changing certain aspects of the camera orientation to your target can greatly affect your model's performance. With geometry-aware augmentation, we can jitter the images and use different transformations to make it look like the camera took a picture from a different angle. On the right, you can see NVIDIA's NERF model, one of our leading models that we've been seeing in this field, actually create a 3D scene based on 2D images. This way you can capture any different orientation of images that you need to train your models on. In order to show off some of these cool aspects in brand new GenAI applications in computer vision, I'll be using the FiftyOne open source toolset, a computer vision toolset that has been used to curate, visualize, and analyze your computer vision data, streamline your annotation workflows. You can find and actually fix mistakes within your data set, correct model failures, and much, much more. So we can actually inpaint in FiftyOne today using a FiftyOne plugin. There's only a few steps in order to get there, where we can take this object detection data set, use a model like Segment Anything to create instance segmentation masks within our data set, such as on our dogs here. Afterwards, once I have my mask created, I can then remove it by using an operator. I can select which class I want to remove. In this case, we'll be removing our blonde lab here. And then our results, we can see that in our thumbnails, the dog has been removed, but once we click in, we can see the original result. Now you can see results can vary, especially for large images such as these, where we still get some artifacts, but with smaller and fine-tuned approaches, you can really bolster your data sets and create all new views using in-painting. The next topic we're going to talk about is generative datasets. And now this is the polar opposite of the synthetic datasets that we talked before, where we're actually creating synthetic images to either be a part or actually be the entire full dataset that we're going to train our models on. And what's awesome about these is that you can get started with a single prompt. It's so easy to start generating these images today. It's fast and cheap. You can go online today and start prompting and be able to get your images in seconds, as well as multiple different APIs now that I can set up and do this at a large scale. And we're just seeing this unprecedented creative control that we haven't been able to see when you're altering data sets in the past. Today, I can just prompt, imagine monarch butterflies, and I can prompt to be able to add more images to my data sets. And I can even tweak it by changing things like, I need this to feel darker, or I need this one to be brighter. Or you can actually just prompt it with anything you want to. Like, I want this to be at my favorite sports team stadium, right? Or as ever crazy you wanted to get, it will work. And we just haven't been able to see this fast iteration and experimentation that allows you to lead to better data sets. Now, this is an important time before we dive into more examples about how you can navigate the progress thoughtfully. The first and foremost thing you need to be aware of is that these models have known biases within them. On top of this, there's types of hallucinations that these models can experience, either from not having up-to-date data or just bugs within the models. So you always have to be careful whenever you're bringing these data in from these models to make sure that they are still meeting your criteria for images. On top of this, we want to make sure that we're maximizing data privacy whenever we're dealing with these things. We want to make sure that we're never actually leaking confidential information that was never agreed upon to be going into certain prompts or whatever it might be when you use these models. And just be sure to learn and understand the current gaps in GenAI. That way you do not fall within them whenever you go into your workflows. So we're going to talk about how GenAI can actually poison your data sets, right? We're also eager to apply GenAI, but where are the shortcomings? How can I spot them? So the first example that we're going to look at is this medical data set. And this medical data set is using a version of a super resolution model that is going to make their images from medical imagery more clear, and they're going to remove any noise, right, that these machines tend to make. And we can see that what happens is that during these models, we're actually, in the term Gen AI, you have to be adding stuff in. We're also removing some stuff as well. And in this case, in images A and B, you can see artifacts are being removed or added, making these diagnoses for these doctors in these ERs or wherever they might be harder because the telltale signs that they were looking for have now been removed by a model, and the model is actually hurting the diagnosis more than it would help. Another big threat that is becoming more and more prevalent is data drift, where whenever you're adding this data to your data set, you have to make sure that it's fitting with all the rest of your data. All this data can be represented. You can imagine in a normal curve like this one on the right, that if you've been adding this new Gen AI data on the right, that we want to make sure that our model is still going to be training to the same normal curve, that we're still following the same distribution of images. And what happens is, even though these images can be stunning, they can look very crisp to us, the hidden patterns within the image are altered. These pictures tell 1,000 words, and there's nothing better today than still taking a picture with a camera to get the best representation of features. Until we get to a point where these Gen AI models can close that gap more, understand that these hidden patterns, what we're training our models on, are still being altered underneath by these Gen AI models. To show an example of this, I will be using FiftyOne to show you this butterfly data set. So I will switch over here. We can look at our butterfly data set, and I've specifically pulled up the monarch butterflies. Within this monarch butterfly data set, I have added 5 Gen AI pictures. Now I'm going to scroll up and down very slowly. I'll do a couple times as well to see if anyone can take a peek and find the Gen AI pictures within. Now they're all labeled monarch butterflies, and they all come at the same angles. Now it's obviously tough to tell, but using FiftyOne, we can actually compute the beddings and see the features that are being extracted from our images. And when we look at this for monarch butterflies, we can see all of our monarch butterflies here on the left, and then 5 specific images that I added in on the right. And when I look at which 5 images these are all my Gen AI images. So even though these pictures, as we saw before, might look exactly like the rest of the butterflies for us, our model knows right away which ones are not. And even on a larger scale here, if I'm to remove some of my views, these monarch butterflies are hiding amongst all my different samples. And even if I was to show all my other samples here, we don't know where these new GenAI models are going to land and if they're fitting properly into our distribution. Using FiftyOne is the best way to find these different embedding gaps, as we see here, with open source tools that you can download today. I will pull up some links at the end here to help you. So let me pop back into my slideshow mode. If you're interested in getting started with these today, you guys hop over to the FiftyOne GitHub page. We have our FiftyOne GitHub page as well as our FiftyOne plugins page, where we're putting most of our new GenAI plugins for you to get started with our workflows today. Also, to help get started with FiftyOne, check out our docs as well as join us on our community Slack, where we're continuing the conversation on GenAI and how it's bolstering our data sets, as well as helping us figure out where these issues lie, where the poisons might be within our data sets.